What if we told you that the very thing that has been feared for centuries could hold the key to creating entire universes? That's right, we're talking about black holes. It may sound like science fiction, but some of the brightest minds in physics and cosmology are exploring the tantalizing possibility that black holes could be responsible for the creation of new universes. In this video, we delve into the cutting-edge research and theories behind the question: can a black hole create a universe? Black hole. Black holes are one of the most tremendous destructive forces in the universe. And while opposites in magnetism attract, the concepts of creation and destruction are conventionally adjacent when it comes to black holes. But what if black holes created something big? Scientist theory. A team of scientists has proposed a new theory where they do. Black holes might not only bend space and time into a singularity of extremely high density, they may also induce a continuous transition between the inside of a black hole and the beginning of a new universe, according to a study recently shared on a preprint server. In other words, the study suggests black holes might burrow into a kind of multidimensional object called a brain and give birth to an entirely new universe in another colossally big bang. However, this idea relies on string theory, a body of ideas with aims to unify all forces in nature. So it's a big maybe, but the idea alone highlights the intriguing mystery that the unknown internal happenings of black holes present us. And bearing a magic spacecraft that can take us through a black hole's event horizon, alive, we can still try to approach it with mathematics. Patching a black hole singularity into a Big Bang. Einstein's vacuum field equations for gravity lead us to a singularity, where the fabric of space-time curves away from the plane. And in black holes, this curvature extends far beyond what we expect in ordinary gravitational fields surrounding stars or planets. It's a place where the laws of classical physics, from Sir Isaac Newton's time, begin to break down. But according to the study, this breakdown in classical physics also happens within Big Bang conditions, when a universe is being born. Jumping forward a few hundred years, quantum physicists hope to find a way to integrate Einstein's theory of gravity into a quantum schema. But any attempt to unify all physical theories under quantum physics would also have to give an account for singularities like black holes and Big Bangs. This is what the recent study purports to do. We propose a way to simultaneously resolve black hole and cosmological singularities by the addition of a single object to the effective field and theory description of space, time, and matter, said the researchers in their study. This object is an S-brane, a relativistic object which occupies a codimension one space-like hypersurface of spacetime and carries positive tension but vanishing energy density, added the researchers. This object violates the usual energy conditions and hence enables a resolution of space-time singularities, using two mathematical representations of the Big Bang and black holes, called the Penrose diagrams of expanding cosmology and the Penrose diagram of the Schwarzschild black hole, respectively. The authors attempt to bring the wavy singularity of both diagrams together, like a patch. If this is possible, and it's a big if, they would create a theoretical description of a black hole, whose singularity leads to a new universe. Nested universes. Although a black hole forming from a star the size of our sun would only be about 2 miles wide, it does not mean that a universe which might originate from a black hole would stay that small. Our universe was small a long time ago and expanded, Poplawski said. From the other side, one would not see our expansion. Essentially, a black hole could seem bigger on the inside than how it looked to someone outside. If anyone survived a trip into a black hole and emerged in another universe, it would be a one-way trip, Poplawski noted. The event horizon of a black hole is the boundary at which nothing inside can escape. In theory, black holes do lose mass, however, as Hawking radiation, particles that emerge from the vacuum right next to their event horizons. Black holes that lose more mass than they gain are expected to shrink and ultimately vanish. This does not mean any universe at the other end of the black hole would cease to exist, Poplawski explained. We would just be disconnected from the other universe, he said. Evidence for a black hole birth. If our universe was born from a black hole in another universe, it would be impossible to cross its event boundary and see the other side, meaning one cannot prove or disprove this idea that way. So how might one test this conjecture? One implication of Poplawski's concept is that our universe is closed. In cosmology, there are three models for our universe, Poplawski explained. The first is that it's closed, the second is that it's open, and the third is that it's flat. If it is closed, and one tries to venture to the edge of our universe, one would eventually loop back to where one started. It would be like walking on the surface of the Earth. If you walk to the east, at some point you come back across the west, Poplawski said. If our universe is flat, and one tries to venture to its edge, one would never reach it, as it continued infinitely. The same would hold if the universe is open, only it would be curved. Poplawski said, this means that if two beams of light were shot into space parallel to each other, in a flat universe they would stay parallel, while in an open universe they would get farther from each other. If our universe lies within another universe, the prediction would be that our universe is closed. Poplawski said, that could maybe be tested at some point. If the universe is closed, if one watches the stars, their light would be visible on the opposite side of the sky. If the universe is really big, the light from those stars might not have had time to do that yet. But maybe at some point, we could see this. Just how are new universes born inside black holes? A star that collapses into a black hole very quickly squeezes down to infinite density and time stops. That's according to general relativity. And basically, that moment when time stops is deferred by quantum mechanics, by quantum uncertainty, and rather than collapsing to infinite density, the star collapses to a certain extreme density, and then bounces back and begins to expand again. And that expanding star becomes the birth of a new universe. The point where time ends inside a black hole becomes joined to the point where time begins in a Big Bang in a new universe. In conclusion, the possibility that a black hole could create a new universe is a mind-bending concept that challenges our fundamental understanding of physics and the nature of the universe itself. While the idea is still purely speculative, recent research and theoretical models suggest that it may be possible and that black holes could play a crucial role in the creation and evolution of the multiverse. Whether or not black holes are the key to creating new universes, one thing is certain. The universe is an endlessly fascinating and complex place, and the more we learn about it, the more we realize how little we truly know. If you enjoyed the video, kindly subscribe to our channel so you won't miss out on our videos.